Welcome back, CS 341 students, to our continuing discussion of a highly selective introduction to C#. And I'm going to start with a poser here. What gets printed? Pause the video, think about it for a moment, and then place your bets. We're going to do more than place bets. We're actually going to run this code. And when we run this code, we see that this code has apparently had no effect. That is to say, if we change the value of the parameters, if we change the value of A to B and B to what had been A, changing the parameters has no effect on the variables out here, on the arguments. You knew that from your study of Java, but C# is different. We can go ahead and write in front of each type the keyword ref. We write this where we declare and implement the method. We also write it here where we invoke the method. All right? And now, instead of 5 and 10, when we rerun it, we get 10 and 5. It in fact did do the swap because C# supports not just pass by value, but pass by reference. If you want to pass by reference, just use the keyword ref right here. A similar sort of keyword is the out keyword. Ref says that you are passing by reference, and if you change the value of the parameter, it will change the value of the argument. Out is the same thing, except it is a requirement that you supply a value, you assign a value inside the method to the parameter. So over here, I've got calculate statistics. I'm going to pass in some data, and I'm going to return two values, a mean and a median, as doubles. I'm going to mark this as out. That says that I must assign a value to mean and I must assign a value to median in the middle of this method. And this, of course, is going to calculate the mean and the median. So let's see this in action. So here we've got our code over here, and you'll notice that as with ref, I've had to write out before the arguments as well as before the parameters. Let's put a little bit of spacing here so we can see what's happening. By the way, you may have noticed the fact that I have nested this method inside another method. Yes, you can do that. It works. And if we go ahead and run this, we see that the mean is 30 and the median is 30. Okay, that's a little bit boring. Let's swap this out here a little bit. Let's put the 20 here and rerun this. And yep, the median is still 30 because array.sort did in fact sort the data. Okay, so that's out parameters. A couple of other points worth noting. We have a concept of tuples. I don't want to dwell on this too much, but it is sort of cool, the fact that you can just arbitrarily bundle pieces of data together. Again, I'm using capital S's here. I really need to change all my notes to lowercase s. I will at some time in the hopefully not too distant future, probably before 2030. And so you can use tuples. You can use them to do things like this. Here's swap taking place just by taking the value of AB and assigning to the value BA. This is pretty cool. All right, and you can use this to bundle out parameters. So instead of using out here and writing out double mean, out double median, we instead return a tuple. So we return those two values right here. Again, you can take a look at this. I'm not too concerned about this, although I do want you to know it. I want you to be able to tell me what a tuple is. Optional parameters, you have the option, hence the name, of either including or excluding arguments. And if you exclude the argument, the parameter has got a value assigned to it. So for instance, if I set the alarm and I've got int hour, int minute, int seconds, if I only specify an hour and a minute, seconds defaults to 0. If I specify seconds, that's the value of seconds. So quite useful. We also have name parameters. This doesn't get a whole lot of use in C#. It gets used everywhere in Flutter and Dart. Again, if you're taking mobile application development, you'll be seeing this a lot. And it really is ingenious, absolutely ingenious, because when you look at the numbers 6 and 30, maybe with alarm, you know hours got to come first, minutes got to come next. But if it was a date and you see three numbers, it might not be clear if the first is the month and then the year and then or maybe the year and then the month. Somehow we got to work day into there as well. It won't be clear. You have to look at some documentation somewhere unless you use name parameters, in which case the code becomes self-documenting, which is a really good thing. Another cool feature of C# is the ability to use variadic parameters. In order to do this, you simply use the keyword params followed by an array. Then if you have a variable number of arguments, those arguments get bundled into the array, and then you access the elements one at a time. So pretty cool and worth knowing about. Exceptions. Exceptions work pretty much like in Java, sorta, kinda. C#, though, does not have checked exceptions. You never have to put something in a try-catch block, unlike in Java. So that can be a good thing from the programmer's perspective. On the other hand, if you want to insist that somebody use a try-catch block, you really have no way of forcing them to do it. So it's got pros and cons. Enums. Enums are extremely helpful if you want to try and keep your code manageable and readable. So instead of using just like numbers, you can use enum. So to create an enum, you simply write the word enum followed by the name of the enum and the values that it can take on. So you're basically creating a new type here on the fly, and we're talking about colors here. It's a lot easier to understand colors.orange as opposed to, say, the number 1. Yes, my favorite color is 1. Good for you. My favorite color is colors.orange. Oh, okay, so you like orange. Not sure why you had to stick colors dot in front, but you do. That's a requirement, at least as of this version of C#. Probably going to change it sometime in the future. You'll just be able to write dot orange. In fact, you might be able to do that already. Have to research that a bit. So you can compare enums as you might expect. You can use enums in switch statements, and you can actually go back and forth between enums and numeric values. So here's an example of that. I've got an enum called meal with breakfast, lunch, supper, and other. These actually have the implicit values of 0, 1, 2, and 3. So I could write meal counts 2 plus plus, incrementing the number of lunches, or I could write meal counts meal.lunch plus plus, which is easier to read, obviously, to use this enum here. So get into the habit of defining enums. Get into the habit of defining enums in their own CS files. Don't embed an enum here. It may look like I'm doing so in this example, but in general, you are always going to want to create your own. And in fact, if you're using the Solution Explorer, when you go ahead and then create a new file, it recognizes that you might want to create an enum. And so it goes ahead and does that. Let's say we had an enum called pieces. And so we could have, for example, I don't know, a pawn, a rook, a bishop, a horsey, queen, and king. Okay, sort of I don't think I've got the order of this quite right. But in any event, it even tells you what their Visual Studio Code even tells you what values they've got. So it's this easy to create an enum. Again, if you have a series of constants, reach for the enum out of your toolkit. Very, very handy. All right, so we've talked about methods, but now we're going to talk about methods in the context of classes. And we want to make sure that we use the right terminology when talking about classes. And so let's look at that terminology now. Everything in a class is called a member. Those members can be fields. Instead of instance variables, we're always going to talk about instance fields or maybe just fields, and then class fields if we need to distinguish fields that belong to a class as opposed to an individual instance of it. Now, this is different from a local variable. If we're talking about a local variable inside a method, we're still going to call those variables. We have constants, and the const keyword is how you declare something to be constant. So for instance, over here, I've got a const int called max age with a value of 360. Of course, if you declare something to be constant, you want to assign a value to it, otherwise the compiler will grouse at you. Constructors and methods, we'll talk more about constructors. We've talked about methods extensively already, and we're going to talk about these next. So let's look first at properties. So here's a fine example. I've got a person called Percy I've created using the default constructor, and I've decided to assign a value, which I can do because these instance fields are public and I'm in a completely different location here. I'm going to assign name the value Sarah and age the value -18. Oh, wait a minute, that's ridiculous. That can't be right. Well, it isn't right, but the compiler doesn't know that. -18 is a perfectly legitimate int value. So instead, what we're going to do is we're going to introduce properties. So what I'm going to do here is I'm going to create a public string called name, and I'm going to use a getter and a setter. So I'm going to have a get, and with that, I'm going to return name. And with a set, I'm going to assign a value to name, and I'm going to do the same thing here with age. All right, so I'm going to have a public int called age. Notice it's capitalized. And get, I'm going to return age. I'm going to show you a shortcut for doing this. Okay, so there's my getter. This is equivalent to writing the whole thing in curly brackets with a return. And then with set, here's where things get interesting. I'm not just going to assign a value to age. I could, but instead I'm going to apply a little bit of logic here first. If value is greater than or equal to 0, and value is less than or equal to, we can debate that, max age, if that's the case, then, and only then, will I be assigning a value here. Let's hope that I got the right number of curly brackets. I do not. We need one more here. Okay, so this is an example of, let's focus on age here for a moment. This is an example of a property. So now, instead of saying Percy.age, I'm going to make Percy.capital-age. This now is working through the property. And when I assign a value to the property called age, the value being assigned, -18, shows up inside this keyword, and this code executes. So this is a way of executing code before you do an assignment. And when executing that code, you can check to make sure that what you're doing is legitimate. Now, this looks just like I was working with an instance field. That's the nice thing about properties. They don't look fancy. In Java, you have to say, get this, set that. They've hidden that entirely in C#. So this is a setter as you would do it in Java. But in Java, you'd have to say Percy.setAge, which is okay. But this is a little bit of syntactic sugar that makes things look better. Now, in this case with name, is there any logic? Well, I might want to make sure that name is, let's see, not equal to null. And I might want to make sure that name.length is greater than 0. That would be a good thing to check, I think. Okay, and so now anytime I assign a value to name, it's going to execute this code. I made a mistake here. This should be if the value is not equal to null. And if the value is not equal, dot length is greater than 0, then I should assign that to name. I could go ahead and fix this because Tella is magnificent, but I'm not going to. I think you should know that occasionally, I know it's shocking, I do make mistakes. So we've got properties with getters and setters. We actually haven't used get, so let's go ahead and do that. Over here, I am going to create another person we'll call this Maurice is equal to new Maurice 24. And let's see, the compiler is not happy because I don't have the right constructor. So let's go ahead and do this. And let's take advantage of this fact. You can see right here, I'm actually just assigning the parameter to the field. I don't want to do that. I want to go through the property. That way I can inject whatever logic I need. Same thing with this dot age is equal to age. Now you notice this is sort of faded. That's because there isn't any ambiguity here. There isn't any need for the this dot. And so we will leave that out. So what we're doing at this point is we're assigning the parameter to the property. And if there's any issues, we'll deal with it later. Now, if I want to go ahead then and then print out, let's see, Maurice's, I'm just going to go for Maurice dot, I'm going to go for Maurice dot name, okay? So this way I am going through the getter. Now, I could go through Maurice dot name, but I generally do not want to do that. So in fact, what I'm going to do, the final bit here, I'm going to make this private and this private. Now I've locked everything down. If I want to get to name the field, I have to go through name the property. Okay, and this is a standard way of doing things in C#. A couple of other points to note. What if for some reason I didn't want to allow someone to change the value of a property? I wanted them to be able to find out what the property's value is, but never change it. Well, all I have to do is get rid of the setter, and now I have basically a read-only property. I can get the value of age, and that's age, but I can't set it. Of course, that means that this is not going to work. So maybe I don't want to do this, but this does illustrate the basic idea here. I'm going to go ahead and restore this. There are times when you might want to create a property, but you don't have any special logic that you need to execute in either the getter or the setter. For instance, I have this class here called point. As you can see, it has a property called x with a backing variable called x, lowercase. And I'm doing nothing special here. X, the property, when you try and get it, is simply going to return the backing variable, and set is simply going to assign a value. Of course, you could do the same thing here with y as well. So there's really no need for all of this, right? All we want to do is get and set a value. Well, C# has your back with auto-implemented properties. All I have to do here is say get and set and get rid of this entirely. There's now a property here, and there is some backing variable, but we can't get access to it. And we would do the same thing here with y, of course. Get and set. So there we have auto-implemented properties. That's simply a property where you have a backing variable, but we don't have access to it and we don't care about it. Now you might wonder, well, since we're talking about the class called point, what is the point of an auto-implemented property? There are many places in the .NET SDK where you need to provide access to properties. You can't just give the tooling an instance field, things won't work. Something called binding is a great example, and we'll talk about binding later on. When you bind, you have to bind to a property. You can't bind to an instance field. And so for that reason, in this circumstance, it would make sense to make these as auto-implemented. There may be times when you need to assign a value to a property, and you can do that as you were declaring the property. So for instance, I'm going to make it clear that this has got the value 0 and that y has also got the value 0. Of course, we'll probably want to have constructors here. So we could have a public constructor called point, and let's say int x, int y, and we're going to do, of course, x is equal to x, y is equal to y. If we had, whoops, let's try that one more time, x and y. If I wanted to create another constructor, public point, a default constructor, let's say, I can chain constructors together using this. And so this constructor, the default constructor, the very first thing it does is it looks for a constructor with two parameters, finds it, executes this code. So I really don't need this equal to 0 here and equal to 0 here, but this shows off the mechanics of it all. And after it's finished executing the constructor that it's invoked, you can then do something specific here if you feel so inclined. So constructor chaining works in C#. All right, a few more topics I just want to cover briefly. Operator overloading. I love operator overloading. There's very few times when you need it, but it is pretty cool. Basically, you can take any operator, or most operators, and you can make it so that they do something different. Here's a classic example where I've got a vector, as opposed to a point, with these auto-implemented properties x and y. And I have now overloaded the addition operator. I now have the ability to add two vectors together. I mean, vector addition is something you can do in math. Why can't programmers do it? Well, they can in C#. So the way you create an overloaded operator is you write public and static, and then the return type for the operator, whatever it happens to be, followed by the keyword operator, followed by the operator. And then if it happens to be an operator that works on two operands, you provide two values here. If this operator was unary, you would only provide one value. And then you can do whatever you want. In this case, when I take two vectors and add them, I want to make a new vector that consists of the sum of the individual fields of the arguments. And so that's what's happening here. And here's a demonstration. If I've got Vic, which is 3, 4, and Victoria, which is 1, 2, I can now say Vic plus Victoria. And Vic, of course, is going to be V1, and Victoria is going to be V2. And this will, I'm using var here, but in fact, this is a vector. In fact, this is a great example of why I shouldn't use var, because now you're wondering, well, what type really is sum? You have probably a pretty good idea. It ought to be a vector. In fact, it is a vector. Indexing is something else that is exceptionally cool. So you have the ability to apply indexing so it'll work with any class. If you have a class, you can ask for an element of that class. Here's an example with solar system where I've got a string array of planets, and here's how I create the indexer. I say public string this int index in square brackets, and you can see what I'm doing. I'm basically providing some backing code to access these individually. So if I created a solar system and I asked for solar 2, the 2 goes into the index, and then planet's index gets returned. Of course, this isn't a great example, to be perfectly honest. I should be using an enum here, because if I was using an enum, then I could write solar of planets.venus, or actually Earth, planets.earth, say. But we will leave this as a fine example. And let's see, we ought to talk a little bit about inheritance. I think this slide shows the basics of what you need to know. Create a class. If you want a subclass, you use a colon instead of extends. If you want to invoke another constructor in the same class, we've already seen how to do this with this. If you want to invoke a constructor in the base class, you use the word base, not super. You'll want to keep this straight. Could I ask this on a quiz? You betcha. And this talks about how we can invoke a method in a superclass. In the base class, if we want to indicate that methods can be overridden, we have to make them virtual. So let's suppose that in the in the animal class, I had a method called make sound. I would declare it to be virtual and whatever types I need here, and for parameters if I had them here. But the point is, this is making it explicit to the compiler. Here's a method. I'm expecting that I'm going to be able to override it, and so you have to write it as virtual. And then in the subclass, you would override it. Now, once you've overridden it, to access the base class method, you would use base dot followed by the method name. You can make methods abstract. You can make methods so that they cannot be overridden. Instead of saying final static like you would in Java, you say sealed. We are sealing this method. And you can use abstract to make abstract classes, which of course, based on your familiarity with Java, that's why I'm saying, of course, cannot be instantiated. Interfaces are also worth knowing about. Interfaces are pretty much like they are in Java. Really, the most important thing I want to point out here is the letter I. The naming convention is if you have an interface, it starts with an I. So you might have a class called database and a corresponding interface called iDatabase. You don't use virtual on the methods in the interface because it's implied. You don't use override on methods that implement the interface. That's also implied. And C# supports polymorphism in the same way that Java does. As with modern Java, you can have instance methods and properties, events, and indexers. And methods can have a method body. So you can check out the documentation for details of that. That's just like default in modern versions of Java. Generics are a thing. C# eschews type erasure, which is also a good thing. So you no longer have to, when you are assigning, if you want to instantiate a generic array, let's say, you can actually instantiate a generic array. You can't do that in Java. Just to show what I'm talking about here, I'm going to go ahead and make person a generic class. And then here, I'm going to make an array called demo. And I'm going to just say new T5. Right? I'm not sure really what this represents, but here's the point. I'm able to say new T5, and at runtime, this will work just fine. This is a vast improvement over Java, where of course you'd have to say new object here, and then you'd have to typecast, and then it would give you a warning about it. A real hassle. Collections. C# unexpectedly in that base class library has lots and lots of collections that you can work with. Everything that you are familiar with from data structures is available to you here, including some that you haven't seen in data structures, but they are there. Now, there are a few probably useful bits of information that follow here. Asynchronous programming, we're going to talk about that eventually. Fortunately, it looks a lot like, well, not like Java, but like JavaScript with async and await. There's a great discussion of it here. You should probably read through these notes and follow all of these links and read them. That's how you're going to become good at C#. You can read and write files. We're going to be doing that in this class. This demonstrates sort of how you do this. This should look pretty similar to Java. I'm not going to go into the details of this right here. I think you can figure this out pretty clearly. It's using file streams and stream writers that are basically just the same as they are in Java. And Rootify is a method that I've written that makes it possible to get access to the root level of a Visual Studio Code project. You'll only need this in Lab 1, and I'm actually giving you this code for Lab 1, so you do not need to worry about the fine details of this. But you should look this over, and if you have questions about it, you can ask in class. All right, I have one last slide here, writing and reading files en masse. I'm going to leave this as something for you to read and study and figure out. Why am I doing this? To remind you, and honestly, to remind me that this is not a class in mobile application development using C#.net. This is a class in software engineering. As a software engineer, it is expected that you're going to learn how to figure out new things. I'm pretty sure the code on this slide is new. And so this is going to be sort of a little mini test for you to see if you actually read this and, to be precise, watch this before class, and we're then going to talk about it in class. Okay, that is it for this second video. I hope you've enjoyed it. Let me know.